Dear students, in this video we are going to see the experiment number 7, Fuzzy C means clustering for the course 20 CS 2032 Machine Learning Techniques Lab. Clustering algorithm is an unsupervised learning algorithm where the similar items are grouped together. Basically, the clustering algorithm will be divided into hard clustering and soft clustering. Hard clustering means a data point belongs to a same class alone. And soft clustering means the data point belongs to more than one class. So based on the membership, the data point belongs to more than one class. And Fuzzy C means clustering algorithm comes under the category of unsupervised learning mechanism, where in FCM, F represents the fuzzy. So fuzzy indicates it is a soft clustering mechanism where each data point belongs to more than one cluster. And C represents the number of clusters. And the M represents that is mean. The cluster center will be calculated based on the mean value of the data points available inside the cluster. So FCM allows the data point belong to multiple cluster with the different degrees of membership. And this is the flow of the FCM algorithm. In the beginning, we have to set the number of clusters, followed by we need to initialize the fuzziness index. This is M. So the M value can be a value greater than 1. M defines the degree of fuzziness. So if we increase the M value, the data point will belong to more than one classes, or it can belong to all classes. So the selection of M itself, optimization process, and if we change the M value, we will get the different clusters output. Then we need to initialize the membership matrix, which is initialized to a random value that represents every data point, how it belongs to cluster 1, cluster 2 or up to cluster n. And based on the initial membership value, we need to update the cluster centers. And cluster center will be calculated as a summation of membership function with the input features divided by summation of the membership function. Based on the cluster center calculated, we have to compute the membership matrix. The membership matrix is calculated based on the distance between the data point and the cluster centers, and basically the distance calculation will be done with the Euclidean distance. And we have to compute the cost function in order to compute the cluster centers, and that cost function need to be minimized. So these steps need to be repeated until we have a maximum iteration need to be reached, or the minimum cost function with the particular termination criteria. And at the end of the clustering algorithm, every data point will be assigned to a specific cluster that has the highest degree of membership. And this is one of the example how the data will be look like before the clustering and after the clustering. Here the number of clusters selected is 3. So our data will be divided with 3 cluster centers that surrounded with the data points. The clustering algorithm can be used for the image segmentation also, where the image will be partitioned into different regions based on the number of clusters. One of the main application of the clustering is identification or detection of the tumors from the brain images. And the performance metrics which is used to evaluate the performance of the clustering algorithm are partition coefficient and the partition entropy. Both will be evaluated based on the membership function. And the partition coefficient is nothing but it is a measure of quality of a fuzzy partition. If the value is very close to 1, the partition will be better. And the partition entropy is a measure that provides the information about the membership matrix. The value of the entropy near to 0 will provide the good partition. And to implement the algorithm, we need to follow the following steps. First, we need to import the Python libraries. and then read the input data. Do the pre-processing to identify if there is any missing value in the data set. If there is a missing value in the particular column, impute that column with the mean of that particular column. Then standardize the data. Then we need to initialize the fuzziness index M and the number of iterations. So before doing the clustering, we visualize the input features distribution using the scatter plot between the two features X1 and X2. And we start to perform the FCM clustering by assigning different cluster numbers, because we have not going to initialize what is the best number of cluster for this particular problem. So we are going to use with the trial and error method. We repeat the clustering algorithm with the number of clusters 2, 3, 4 and 5. So every output clustering we are going to evaluate with the Silhouette score, and the number of clusters with 2 to 5 which having the maximum Silhouette score, and that will be identified as the optimal number of clusters for the particular problem. Then we have to plot the curve against the number of clusters and the Silhouette score, so that we can able to know in which number of cluster we are getting the good Silhouette score. That will be taken as an optimal number of cluster. So once we fix the optimal number of cluster, for that particular cluster value, we have to display the cluster centroids, and we need to visualize the clustered output using the scatter plot with the colored label for the each cluster. For example, here the number of clusters 3. So we need to display the cluster centroids, and also each data point belong to which cluster, that we have to label it with different colors. And finally, evaluate the performance of our clustering model using the partition coefficient and the partition entropy. This specifies the sample FCM code that you have to hard code step-by-step procedure in order to do the FCM clustering. First, we have to initialize the membership matrix. So to do that, we are initializing the membership matrix with the ones as random values for all the values of our membership function. So the membership function means each input, how much membership it belongs to that number of clusters. So what is the membership assigned to each cluster for that particular instant, and that will be randomly assigned in the function called as initialize membership matrix. So once it is initialized, in every iteration we have to compute the centroids based on this membership function. So we need to compute the centroids. To calculate the centroids, we know that we have to use the sigma of membership function into x divided by sigma of mu. So based on that, the numerator and the denominator will be calculated and the centroids get computed. So once the centroid get computed, the next step is based on the centroid calculation, we have to update the weights. In order to calculate the weight, we need to compute the distance between the data point and the centroids by using the Euclidean distance formula. So once it is computed, based on that, the membership function values get updated. So this procedure gets repeated with the number of clusters is 2, 3, 4 and 5. So every cluster executing with FCM, we calculate the output with the Silhouette score. And the Silhouette score for which cluster value is a high value, that will be taken as a best number of clusters. And once we identify the best number of clusters, we just display what is the cluster centroid computed for that, and then we try to plot the value, that is using the scatter plot with the colored label. We just give the cluster values along with the centroids, and we compute the performance by using the partition coefficient and the classification entropy to analyze the performance of the clustering algorithm. So once you get the fuzzy membership matrix, we have to assign each data point to the specific cluster based on the highest degree of the membership assigned to that particular data point. I hope you got a clear idea how to execute the FCM algorithm in a step-by-step procedure. Thank you.